Right, so yesterday didn't go that well, but the good news is that I went through, I was so unhappy with my code from yesterday that I went through and basically cleaned it up and rewrote it and made it really nice, pretty nice and clean and short. Um, and really the important thing that I did was I said I don't need all that linked list garbage I did. All I really need to do is for each node, which is an int, what is the next node, which is an int. And I can just use a dict for that. So that's what I did. Is I basically said I have this dict of next, and if 3 goes after 4, I say next 3 equals 4, and so on. And then when it comes time to remove and insert nodes, I just changed those handful of pointers in the dictionary. I cleaned up the rest of it too. But it ended up being much simpler, a tiny bit faster, and cleaner. So, and it wouldn't have allowed a lot of the bugs that I made that were enabled by me doing everything in a too complicated way. So I'll put that in GitHub, and if you want to see my clean solution, that's not my dirty solution, you can check it out, or you can ignore it. I don't really care. The other thing that's kind of fun is that I'm doing this startup where you are a continuous glucose monitor, and it monitors your glucose all the time. So you see if you eat candy, it like spikes way up. And when I looked at my thing for last night, when I was getting stressed about this problem, the glucose spiked way up as well. So advent of code is bad for your blood glucose, apparently. At least if you get stressed about it and can't figure it out. So all the more reason to figure out fast and to do a good job of it. So let's hope that today we figured out fast, do a good job of it. Someone on YouTube said today is going to be the big breadth first search maze crawling thing that we've been dreading all year. So maybe it will be, in which case it will suck. But let's see. Your Japanese tropical island. What if you're renovated? You can't even reach the check-in desk till they finish installing the tile floor. The tiles are all hexagonal. They need to be involved in a hex grid with specific colored pattern. Not in the mood to wait, you help figure out the pattern. Tiles are all white on one side and black on the other. Start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. Remember the information clue. You see a list of the tiles need to be flipped over. Each line in the list identifies a single tile that needs to be flipped over by giving a series of steps starting from a reference tile in the very center of the room. Every line starts from the same reference tile. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, north, west, and northeast. These directions are given in your list respectively as this. Tiles identify a series of these directions with no delimiters. For example, east, southeast, northeast, east identifies the tile you land on if you start with the reference tile and then move one tile east. Each time a tile is identified, it flips from white to black, from black to white. Tiles might be flipped more than once. For example, one like east, south, east, west flips tile immediately adjacent to the reference tile. One like flips itself. Here's a larger example. The above example, 10 tiles are flipped and 5 more are flipped twice. All these, a total of 10 tiles are black. Go through the renovation crew's list and remember which tiles they need to flip. After all the instructions have been followed, how many tiles are left with the black side up? So start with the white side facing up. So basically we need to figure out where do we end up. And here is how I want to think about this. And there was a similar problem to this last year. So this is the larger example. And let's say raw equals this. And so we need to think, how do we want to represent and we can represent by saying, and let's look at these hex tiles now. Let's look at a hex grid. And so I start here, and I can go north, northeast, southeast. So you can't go east or west, right? So in particular, if I start here, I have an X column, which will go 1 and 2, and a Y column, which will go up and that. Okay, so I think that tells me what I want to do, which is as following. So first I need to write a parsing function. Def parse raw, which is a string, is going to go to a list of strings. Okay, and typing import list. Okay, and so let's say directions are north, northeast, northwest, south, southeast, southwest. Is that right? Let's double check this. No, because it's turned sideways. So it's east, northeast, southeast, and west, northwest, southwest. And so if I do this, east, west, why am I trying to draw this? Northeast, northwest, and then southeast and southwest. Okay. Oops. Okay, good. And so what I want to do is say out equals this, while raw, if raw dot starts with or let's say if raw2 in northwest, northeast, southwest, southeast, then out dot append raw2 and raw equals raw from 2 on. Otherwise, out dot append raw 1 and raw equals raw 1. Okay, and then return out. So let's just make sure that that works. For example, if I do this, and then if I parse this thing, okay, well that didn't work. Let's think about this. Duh, because this should be raw 0. Northwest, west, southwest, east, east. Okay, and then the second thing I want to do is I want to identify, and what do I want to call this? Let's say, whoops, find tile, and let's say steps is a list of string, and this is going to return a tuple of int, and like I said, returns final x, y. Okay, and so we'll say x, y, x equals y equals 0 for step in steps. If step equals, what do I got, e, then x plus equals 1. Otherwise, if step equals northeast, and I'm going to call these, yeah, they're halves. X plus equals 0.5, y plus equals 1. So this is actually going to be a tuple of float and float. Elif step equals northwest. Yeah, I'll just go around counterclockwise. X minus equals 0.5. Y plus equals 1, L if step equals south west, x minus equals 1, L if step equals southwest, x minus equals 0.5, and y minus equals 1, and otherwise if step equals southeast, x plus equals 0.5, and y minus equals 1, and then return xy. Okay, and so now $10 are flipped once, 5 more are flipped twice to black, then back to white. After all these instructions, how many tiles are, okay. So now I want to say def count black tiles, which is, I'll just say raw, which is a string. It goes to an int. And I want a counter. From collections, import counter. And what do I want to do is for line in raw dot split on new lines, steps equals parse line, xy equals find tile steps, counts equals counter, counts x y plus equals 1, and then I want to return sum v mod 2 equals 0 for v in counts dot values. Okay. Actually, no. Yes. And so then assert that count black tiles of raw equals, and it says 10 should be black. So let's try that, see if it works. Assertion error. Okay, count black tiles raw. It says 5. And why is that? 10 tiles are flipped once to black, and 5 more are flipped twice to black. Print xy line. So let me run it again and see what happens. I thought I was being clever, but apparently my clever solution didn't work, so I wasn't being that clever. I was being stupid. I want v mod 2 to be 1, and because that's what'll be black. Okay, good. So, like I said, I was being stupid, and now I'm not being stupid, so let's get the actual input. Okay, and print count black tiles lowercase raw, and now let's run this. 488. So that's the right answer. Continue part 2. Tile floor is meant to be a living art exhibit. Every day the tiles are flipped according to the following rules. Any black tile with 0 or more black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles is flipped to black. Here, tiles immediately adjacent means 6 tiles. Rules apply simultaneously to every tile. Put another way, it is first determined which tiles need to be flipped, then they're all flipped at the same time. For example, given the number of black tiles facing given as follows. Executing that tile 100 times, how many tiles will be black after 100 days? Okay, so So now we want to do, this is another game of life. Game of life. Every day, every tiles, rules are as the given number of days are. Tiles are all flipped. Here tiles are flipped simultaneously. After a given number of days is follows. Okay, def game of life, and let's say black tiles is going to be a set of tuple of float float. Let's say point equals hex equals tuple of float float. And so let me do, hex is probably the wrong one for that, but that's okay. Game of life, and actually let me start with raw again. And actually let me factor this out and say find black tiles raw, which is a string, and that's going to return a set of hex. And let me do this and say return k for kv and counts.value, counts.items if v mod 2 equals 1. Okay. Dict hex int equals that. Find black tiles is going to return that's fine, I'll do it like that. Okay, and now to count black tiles, I just say black tiles equal return len find black tiles raw. Okay, good. Okay, so now again, yeah, I'll just do black tiles is a set of hex, and it is going to return num steps int, and it's going to return a set of hex as well. And actually, I'm just going to call it step and do it this way. That will be easier. And then I'll just run it a bunch of times. And so now what I want to do is I want to say new black tile is 0 or more than 2 black tiles immediately adjacent to it is flipped to white. So again, you know, let's say def neighbors hex, which is a hex, and it's going to return an iterator of hexes. So let's add in an iterator. And again, let's say xy equals hex. Yield x plus 1 y, yield x minus 1 y, yield x plus 0.5 y plus 1, yield x minus 0.5 y plus 1, yield x plus 0.5 y minus 1, and yield x minus 0.5 y minus 1. Okay, and so those are my neighbors. And so here's what I want to do. What I want to do is say neighbor counts equals counter. For tile in, let's say for hex and black tiles, for neighbor in neighbors of hex, neighbor counts neighbor plus equals to 1, right? So I start with every point, every black tile, and I just say for each of its neighbors, it gets 1 neighbor count. And so, you know, if I have 2 tiles that are next to each other, it'll get 2 neighbor counts. So I think that'll do the right thing. And then what I want to do is I want to say any white tile with exactly 2 black tiles is flipped to black. Any black tile with 0 or more than 2 black tiles is flipped to white. So basically, return, let's say, hex for hex in black tiles if one of 2 things happens. It's a black tile that has exactly 1 neighbor. Hex, and so let me do it this way. Hex count in neighbor counts dot items if either hex in black tiles and count equals 1 or hex not in black tiles and count equals 2. Is that the right logic? Any black tile with 0 or more than 2 black tiles is flipped to white. So that means that only a black tile with 1 neighbor will stay black, and a white tile with 2 neighbors will go black. Okay. So now tiles equals find black tiles for raw, and let's say for I in range 10, tiles equals step tiles, print I len tiles. So let's run this and see. Let's see if it's doing the thing I think it should. So no, 10, 13, 17, 19. Okay, then we're black tiles. Let's do this print tiles and print I print tiles and print step tiles, and we'll see where I went wrong. So let's figure all these out. Y is negative 0.51. And let me print neighbor counts. That will help as well. So 1.0, negative 1.00 has 5 neighbors, 3 neighbors, 2. This is going to be really hard to debug. Okay, so I have 1.51, and so he can go west, east, this is northeast, northwest, southeast, and southwest. So that looks reasonable. I think that looks reasonable. For hex count in neighbor counts.items, print hex has count black neighbors and is hex in black tiles black. Okay, so let's run this again. And so I want to say any black tile with 1 and any white tile with 2. So that's 1, that's 2, that's 3, that's 4, 5, 6. So let me do the following. Def describe hex. No, I don't want to do that. If okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. It is 10. So and it's saying I should have 15. So let's see what I screwed up. Any black tile with 0, so east, west, northeast, northwest, southeast, and southwest. So that's right. And the find tile seems to work fine, so that's okay. So let's see if there's some logic here. Neighbor counts equals counter. 4 hex and black tiles. 4 neighbor in neighbor's hex. Print neighbor counts neighbor plus equals 1. Alright, let me just try doing it like more explicitly and see if that works, because somehow that's not. So let's say adjacent equals equals NB for hex and black tiles for NB for hex and black tiles for NB in neighbor's hex. Okay. And let's say candidates equals black and let's say from black equals hex for hex and black tiles if some NB in black tiles for NB in neighbor's hex equals 1, and then from white equals hex for hex in adjacent minus black tiles if some NB in black tiles for NB in neighbor's hex equals 2. Is that right? Any black tile with 0 or more than 2 black tiles is flipped to white. So that means more than 2. God damn it. Did I not read the thing right? Is it really just as simple as more than 2? Am I really that stupid? I think I am. And more than 2 means that 2 is okay. So 15. God damn it. So dumb. So dumb. So dumb. Again, I can't read. step tiles print len. 15, 12, 25, 14, 23, 28, 37, 49, 37. God, so stupid. Okay. And now what's the question? Do it 100 times. For blank in range 100 tiles equals step tiles, print len tiles, 4118. All right, so that wasn't too bad. I mean, it was bad, but it was bad because I don't know how to read, and I read the problem wrong. And what else is new? The one thing I did that was maybe non-obvious and a little bit weird is the way that I represented these hex tiles as so. I wish this were sideways, but basically I said, you know what? If I think of the center of each of these, right? The center of this is at 0, 0. The center of this is at 1, 1/2. The center of this is at 0, 1, and so on. So I'm just going to represent tiles as the center. And I can do that by basically, doing it this way. And the parsing could have been tricky, I guess, because when you see an N, it could be northwest, northeast, southwest, southeast. But because we know that north and south aren't directions here, that basically check for northwest and northeast, and if you see those, it has to be that. Otherwise, it's N. So that's pretty simple. And then this is a trick that I think someone pointed out to me last time we did Game of Life, which was basically that if I count up the neighbors this way, and then I don't have to do all the adjacent and check. Basically, in one step, I do the neighbor counts and then return the values. So, so this actually wasn't that hard a problem, I guess. It was. The thing is that because of the hex, like debugging it was really tricky, but other than that, not too bad. So that's that, and that's day 24, and historically day 25 has been pretty easy, so let us hope that day 25 is easy as well, and then we will be done. Cool, so I'll see you next time.